Hi, welcome to the video about solving compound inequalities graphically. Don't even have to write much algebra down at all. We're just going to look at the graph of functions and write their solution. So if we're asked to solve, again, we're wanting to find the x values that make this statement true. We want to know what x values make the output of the function, that's what f of x means, between -2 and +4. So again, we want the output values to be between -2 and +4. That's what this three-part inequality is saying. So let's look at the graph. The output values are the y values, and we want to know when is that between -2, getting my little straight edge here, there's -2 on the y, and +4. Here we go. Sorry, made a pretty messy line there. Let's try that again. There we go. So when is the function between these two values? So my function is this curved line, and I'm interested in the parts of that function that are sandwiched between -2 and +4. Okay, now again, if it says solve, we're looking for the x values that go with that. So my x value starts at -6. Why did I just use a parentheses there? Yep, because it's not equal. And that region stops, and I need right at this point, which corresponds to that value of -4. Okay, now I've got this other region that I've shaded. Again, we're looking for the x values, so I go up, and there we have 0, and stops when I get to 2, 4, so I'm coming down to that. So the solution is -6 to -4 together unioned with 0, 2. Now let's look at the same function. So we don't even know what the function is symbolically. It's just this graph, but now we're looking at the compound inequality with an OR. So we want to know when is the output less than -2. So I'm going to color code that in red. So here we go. Here's -2. That's our y value of -2. The function, when is the function less than -2? So we want to go below less than. This is when the outputs are less, because those outputs are -2.1, -2.5, -3, all the way down to -4. And we also want to know the outputs could be greater than 4. So greater than 4, 4 is right there. When is the function greater than 4? Well, it's greater than 4 up here, because those outputs go 4, 5, 6, 7. It's also greater than 4 on this right side region. So again, this has an output of 4. That function value would be 5, 6, 7. So we're looking at these two regions, that red region and that blue region. Again, if we're asking to solve, we want to know the x's that go with this. So I'm going to drop down to the x-axis, and our region, this blue region, ends at -6. Could it be equal? Yes, it could be. It says equal to +4. And again, that region is to the left. It's when I plug in values that are smaller or less than -6. Kind of continuing with this blue idea, this part that's f of x greater than 4, I'm looking at this point down on the x-axis, 2 greater than, because it goes to the right, that blue region of that function goes to the right, and that is for f of x greater than or equal to 4. But now we have to also consider this red part that we shaded. So we go up to the x-axis, and we're at -4. Why did I use a parentheses? That's right, because this part of the inequality is strictly less than -2, not equal to. And then I go up 0 right there. So our solution to the compound inequality f of x less than -2 or f of x greater than or equal to 4 is 3 different parts. I'm going to go just left to right along the x-axis, just like we would go left to right along the number line when we were solving those inequalities. So starting from left, I have -infinity up to -6 bracket, union together with -4 to 0. And I have another union because there's another region involved in the solution, +2 to infinity. So that's the solution. Now, let's look at these both together. Let's see if we can zoom out a little bit. You've got them together on your paper, so I want to make sure we can see them on here on this screen. So what do you, kind of looking at these solutions, what do you notice? Or the graphs? They're kind of opposite of each other. You'll notice that this interval is what is missing in this little split here, and that 0, 2 is what's missing right there. It's kind of the way that I set up the problems, but it's also kind of the way that this this graph, so if we want something between or something outside of that, well, that's kind of the difference between the way that I set these problems up. Now I want you to try using Desmos to graph f of x is equal to the absolute value of 2x minus 3. And once you graph that in Desmos, I want you to solve graphically 2 different problems. 2 is less than or equal to f of x less than or equal to 4, which means when is that function between, the output of that function between 2 and 4? And then the other compound inequality is f of x less than 2 or f of x greater than 4. So again, graph that function on Desmos and solve graphically those 2 inequalities and bring your solutions to class.